3D printing technology has been great for rapid prototyping, but poses environmental problems. Hobbyists report that on average 50% of their prints find their way to the trash, and a single university campus can produce 600 pounds of 3D printed waste each year. Although some types of 3D printing plastic can be recycled through conventional means, many cannot. To reduce 3D printing waste, we've designed a system that takes prints from one of the most popular forms of 3D printing plastic, PLA, and converts it into recycled filament. We call it REUSD, and will make the first prototype freely available to UBC students. REUSD features several modules that function in series, starting with solid 3D prints and finishing with spooled filament. The process begins by slicing prints using nichrome wire, which heats up when powered by a wall outlet and is enclosed in a 3D printed box for safety. This eases the load for the grinder. The sliced prints then enter the grinder to be shredded into smaller pieces. These pieces are screened by a mesh which catches those that are too large for our extrusion system. The grinder is run by a 1 horsepower motor through a 200-to-1 gearbox. Everything is fastened to a platform to make sure the 3 parts don't shift relative to each other. The ground PLA then enters an aluminum cylinder which is wrapped in heating tape, controlled with a thermocouple to bring it to the required temperature. A piston pushes PLA through the cylinder. To do this, a DC motor directly drives a small pinion gear which turns a larger gear, reducing the speed in the process. This larger gear, held in place by a mounted bearing, is threaded through its center, which holds a threaded rod. As this gear rotates, it generates a force which moves the rod up or down. The piston is attached to the bottom of this rod and travels through the cylinder over a 3-hour period. This forces the PLA to extrude through a precision machine hole at the base of the cylinder. The final filament is extruded from the cylinder at a high temperature and must be cooled to solidify. It is drawn into a bath of cold water, which is circulated by a pump. Once it is sufficiently cooled, the filament is wound onto a spool, and after air drying, this recycled filament is ready for use. Once completed, our final design will be housed in Integrated Engineering's club space so that UBC students can drop off old prints to be reused. Thank you.